Hello, everyone. Thank you for joining this session. We will be talking about Tmedia 1+1 solution and high availability in general for the telecom systems. So here, if I start, what we will cover here, high availability, Tmedia 1+1 solution for high availability, and then the physical connection you need to do on those devices, installation and configuration. I put them in one group because it's very short section, status and monitoring of the system. So if we start here with high availability in general in a telecom environment, what you want to have is continuous operation in case of failure of any component. So the HA schemes are usually made for only one failure at a time, but of course it can support many types of failures. The goal is to identify the failure quickly and fix it so that it becomes high availability again in all environments. When we talk about the hardware, the real way to do HA is to have two physical units in your system, because these physical units can fail for whatever reasons. These are electronic components, so they could fail. And then the only way to make sure it doesn't fail is to have two independent physical units. So two telecom units, but then you connect these devices to Ethernet switches, right? So again, you need to have two Ethernet switches to make sure that if one of them fails, it takes over, all the traffic can be taken over from the other Ethernet switches, okay? And then for each of those components in the system, we want to have our dual power supplies. Power supplies are known to be the most vulnerable part of a system like this, so we like to have dual power supplies. When you talk about the network, we need to have diversity, right? These connections are passing on physical environments, and these are passing in roads, these are passing in bridges and stuff like that. So you need to have diversity so that your traffic continues to pass if ever something goes down. And some of the diversity could also be satellite link or something like that. So you need to make sure that these go through different physical paths. TDM lines, right? Because your T1s, fibers are going on the network, so they need to go in physical paths. And your Ethernet routing, well, your packets need to be routed through different networks, physically, and that's sometimes difficult to make sure that your packets are going to two different physical networks in your environment. There are applications running in the system, so you need to have backup applications with checkpointing. Okay, that means that when an active application is running, you need to send information to the backup application so it stays in sync with the primary application. So if ever something happens, either that application restarts without having other effect, or the secondary application takes over and captures all the high availability information so that it can continue to work uh, as normal without affecting anything else. The other thing that is important in a high availability system is to quickly identify issues with the system. So it doesn't mean the system goes down. It just means that there's maybe one interface, one device, one network that is down. So you need to do monitoring of all these components to allow you to identify the source of the problem. Once that problem is identified, you need to have an action plan to decide how you're going to troubleshoot this or replace a unit or replace a cable, reconnect a cable, something like that. You may need to have spare units, but you need to prepare in advance so that you are ready in case of anything that goes wrong in those systems. There's two main ways when we talk about telecom units to do your high availability is to have an active system. So these are two independent systems. They don't talk to each other. They are run by themselves. And this is really useful, for example, when you do signaling relay, where then your signaling is being sent across different paths like this. And you have different messages going through both systems. The end system sees this as just one network. and that works fine. So it's very good for signaling relay type application. When you talk about media, then it's a bit more tricky because you will have media going to one device like this and media going to another device like this. And you need to have double capacity to be able to accept this. Okay, so that means if one system fails here, you will lose like half your capacity of a system. And that's when the 1+1 system becomes interesting, is that you can configure all your capacity going through your active system. And then if something happens with the active system, then everything can go through the standby system. And here what you have is checkpointing between the devices, make sure the information is relayed to the standby unit so that everything can be activated or reconfigured on the standby unit. Okay? So when we talk about the Tmedia 1+1 solution for, well, okay, so the active solution is available. So you can have this, you use standalone devices, units, and then you can install these and this works fine. If you want to have the 1+1 solution, this is where I will concentrate this presentation. So you will have configuration replication between the primary unit and the secondary unit. So anything that you configure here on this device will be automatically replicated on the secondary. So if ever something happens on the primary device, secondary has all the information to reconfigure everything. Then you have an application heartbeat. So every time there's something that happens on the primary that is important, it will send that to the secondary device so that it keeps in sync with the primary. In a 1+1 system like this, you have now a topic of master and slave. Okay, so one of these devices will be master and the other one will be slave. It could be primary to secondary or secondary to primary. And there's negotiation done between the two devices to decide who is the master. There's very few decisions that are made by a master of a 1+1 system. But for example, who is activating the replication here is what the master will decide. You have to allow this, you have high availability communication between the two systems. It's always a redundant connection. And these are important links to be monitored. So they need to be up for this to be working. If one of them fails, it's fine. If two of them fail, then they can't be any more a replication or heartbeat. So it becomes an important problem in the system. So here I will go through the different parts of the system. One is the TDM port redundancy. So you have your 1+1 system here with your primary, secondary, and your HA links here. And you need to put a patch panel in front of those devices to allow to split the information to the two units. Right? So the signal that is received from the TDM network here is being duplicated through this patch panel. Right? So the data comes here, it's being splitted and sent to both devices. So both devices are receiving the same information here. Right? The patch panel here has three connections on it. One is going to the primary device, one is going to the secondary device, and one is coming from the network here. The example I took here is with the fiber OC3 STM1 configuration. In this case, the network fiber is not protected. Okay, so if ever there's a failure here, then you lose all the traffic in the system. So I showed the receive, but the transmit is different, meaning that both devices cannot be transmitting at the same time, or else it will be confusing this signal here. So the transmit signal is selected between the primary and secondary unit. So for example, in this case, the primary unit has the laser on, and this will send the traffic out to the patch panel and to the network. And the laser will be off on the secondary device so that there's no interference. And there's communication between those two systems here to decide who is the one transmitting the traffic. If ever there's a problem with the primary unit, the secondary unit will start transmitting. All right, so there's different ways that this can happen. It's possible that this device goes completely down. So that's easy to detect, and the system here will be selected as later on, and this automatically will go down because there will be no traffic anymore because the unit's completely down. There's possibilities that it's not, there's less major failure here in those devices. And the way this is done is that there is heartbeat inside the system. And if there's no, and this is made in hardware, right? So there's a hardware heartbeat in the system. And then if the watchdog runs out of time, it will force the unit to completely shut down and restart. Okay, meaning that the laser will also go off in that case. So this is important here. The communication is important so that the system decides who is transmitting through this patch panel. Everything is reestablished on the secondary unit, so all the traffic is being sent normally at that time. So I showed that the STM1 is not protected. So if you want to protect the STM1 device, you need to use your APS, automatic protection switching. So you have on those devices 2 fibers. These 2 fibers are connected to this 1+1 patch panel and sent to the network. If ever one of those cables go down, the second one will still be active. The switch over from the main fiber to the APS fiber is done automatically in a system like this. So you just need to, when you configure the system for OC3, you just need to say, yes, I want to have APS, and you need to connect it like this in the network. Of course, here you need to have this capability from the network, an APS connection. And normally this would probably go to two different paths to have diversity, right, to go to the other system. Just one thing I did not mention as well is that this patch panel is passive, so there's no power supplies or connections or configuration to do on this patch panel. It's automatic. When we go to the voice over IP side, so voice over IP is not only SIP and RTP, it can also be SIGTRAN traffic, it can be H248 traffic, it can be management traffic. So these VoIP ports that we have on the systems are made for all kinds of traffic. These can be used independently. So you can use only, for example, VoIP 0 to carry, let's say, SIP traffic. That's no problem. You can do that. But in general, we want to have bonding on those ports. For example, bond VoIP 0, VoIP 1 here to the IP network. And if one of them fails, automatically it's taken over by the other ports. When there's traffic there, it will always go through one port only and not through the other port. Unless it fails, then it's going to go through the other ports. When you configure these ports here, you can have it on either as untagged or on different VLANs, and you can have multiple bonding groups on different VLANs or independent. So you can mix also independent and bonding modes here. And just one thing I need to mention here is that you cannot use lag on these ports, so link aggregations. It's a different protocol than what we're using for our bonding, so it needs to be separate links viewed from the IP network, Ethernet switches, and we do the bonding on our side. Okay. So this is a protection on one system like this. But if you have a 1+1 system, then you have your VoIP 0, VoIP 1, and VoIP 0, VoIP 1 on the secondary unit. Okay, so when you configure this on the system, it will automatically be also configured on the secondary, but not active. So there will be no IP assigned to those ports and no messages sent. Okay. However, if there is a failure of a unit, then it will switch to the secondary unit. Okay, so the secondary unit will activate its port, configure its IPs, and also send a reverse ARP here to make sure that the IP network knows that all the ports have changed. Here are the new MAC addresses you need to use on those ports. And this is where the traffic needs to be going. Right? All the media and IP traffic is reestablished, the signaling and everything automatically when doing this. So this is all automatic on a system like this. And of course, here what we mentioned is that we would be a good idea that those VoIP ports are on different Ethernet switches, so that if one thing happens with an Ethernet switch, it doesn't affect the traffic of everything. Okay? So even if there's only one port here that goes down, traffic would still go through the second Ethernet switch. It's not mandatory. Some Ethernet switches are very good at redundancy and everything, but we suggest to use two switches like this. Just a quick talk about the H248 mode. So H248 mode is controlled. These devices are controlled by a media gateway controller. Okay, so you have H248 communication going to both units like this. And then what happens is that all your media traffic is going through your devices. Right? So when we use H248 mode, we have only media here. All the media is being sent to one of the units like this. If something happens with the primary unit, everything is being sent through the secondary unit. Your media will go here. This is also automatic. So the media gateway controller will know that it's a new connection here, but nothing has changed. All the traffic is still available, and it's running on the system. Okay? So this is all automatic. When you configure a 1+1 system, you don't need to specify that you're in H248 mode or anything. When you configure H248 and you're in 1+1, automatically you have this protection built in. If we go just a bit more in details of inside these devices, then you have multiple applications running. For example, for the web interface to access the system, you have SNMP module running, call trace module. So these are independent application. And what happens is if one application fails, it will just restart. So it's instantaneous. If it fails, it restarted. And most of the time, it doesn't affect anything because the application will resynchronize when it starts, and it just continues normally like this. It's possible that for some reason the application fails and cannot restart. Okay, in that case, the secondary unit will take this application. It will fall back, and secondary has all the synchronization information because this is done with those links here. Everything is stored on this system as well, so it will resynchronize. In general, if there's one application that fails, only one application will be running on this device here as a primary. The others will still be running on this system. In some cases, all the applications are switched over to the secondary, but it's rare. For all these scenarios, I put a link here. I will show you that link later on our wiki site. So docs.telcobridges.com, you have all the information you need there, and this is the specific link for that. Okay, if I move on to the physical connections, you saw this separately, but here I show you everything that needs to be connected. So you have first your management interfaces. So you have one management interface for each of the devices. Then you have your voice over IP ports here, 1, 2, 3, 4. So each one have 2 ports. These the thing you have to be careful here on the IP network is if you are using, let's say, bonding here on those VoIP ports, and you have specified that you want to be on a specific VLAN, let's say VLAN 10, okay, you need to make sure that VLAN 10 is also available here. So it needs to be available here and here on these 4 ports, okay, to make sure that the traffic flows normally. There is high availability communication between the two systems here. It uses 2 ports, though these are two dedicated ports called ETH0 and ETH1. You have these on all the devices, and you only need to connect them straight between the two units. They can go through an Ethernet switch if you want as well, but you need to specify, you need to add specific VLANs for these. They use VLAN 710 and VLAN 711 for these two ports. So you just need to make sure these are configured. But, in general, we connect them directly. It's very simple in that case. Doesn't use up Ethernet ports as well. And then on a TDM, we already talked about your main and APS. So that's to protect your TDM network, and the patch panel, which is your passive patch panel here. Okay? So here I show the connection for OC3 and STM1 and for the TMG3200, but we also have the TSG3200, exactly the same configurations you have here on these devices. If you look at this, the patch panel for OC3, you have three segments in the patch panel. First segment is from the network. So that was on the right side of the previous diagram. And you have your STM1 connection and APS connection here. Here it's the main connection and the APS connection. Okay. Then you have to the primary device, same thing, and to the secondary device. So you will have 6 fibers in total, 2 from the network, 2 to the primary, 2 to the secondary device. There are 2 additional ports here, and these are for synchronization. All right, so on TDM networks, you want to be synchronized, and these are bits port we can use for synchronizing. So you can receive those connections from your bits timing service inside the CO, and then these will go to the primary and to the secondary devices, so that if ever there's a failure, then the bits synchronization will be sent to the correct device here. And I just want to show you here in the camera, I have the real patch panel here. So you see those fiber connections here, right? You have the LC type connectors here, and then you have your 3 ports that you connect and the bits ports that you connect to the devices. For the DS3, it's exactly the same thing on the IP network. Everything else here is exactly the same as the previous slide, except here you will have a DS3 1+1 patch panel, and you will have your up to 3 DS3 connections connecting to that patch panel, and your 3 DS3 going to the network. If you look at the DS3 1+1 patch panel, slightly different than the one before, because these are coaxial type cables here. And you will see that your network connection will be separated in different location on the patch panel. So you just have to be careful when you connect them. These ones will be to the primary, and 1+1 will be to the secondary TMG device. If you have the T1E1 version of the system, you see all of this here is still the same. Here you will have, instead of other types of connection, you will have SCSI cables connected to that patch panel. So these cables are provided when you have the 1+1 patch panel. And then you will have here 1 or 2, depending on how many T1E1 you have. So here, each of the devices are 32 T1 or E1. So if you want 64, you need to put 2 of those patch panels. So you will have SCSI cables connected to one patch panel, SCSI cable to the other patch panel, and all your T1E1 connections will be from the patch panel out to the network. So if I show you here what it looks like, so you have your SCSI connections here. I didn't show the cable, but it's a little cable which has these ending here, which connects from the Tmedia to the patch panel and to the primary, and then the same cables to the secondary here. And from the network, then these are RJ48C type connectors, like similar to RJ45, but different pin out, of course, for T1 and E1 here. Okay, so the T1 connections are in the front and the SCSI cables are on the rear. On the other patch panel I showed you, everything is on the front of the patch panel, but of course it can be put either in the front of the rack or at the rear of the rack. And you have the same for the TMG 800 or TSG 800. The slight difference is that the TMGs 800 have two management ports. You can use one or two of them. That's fine. They have the same HA links here, VoIP 0, VoIP 1. However, here the patch panel are slightly different, is that you have your T1E1s connected to the patch panel and T1E1s connected to the network. It supports, these devices support 16 T1E1, but the patch panel supports 8. So then you need to have two 8 T1E1 patch panel here to have a total of 16. If you look at the patch panel itself, you see that there's only connections in the front of the patch panel. It supports up to 8 T1E1 from the network, 8 ports, to the primary unit, 8 ports, and to the secondary, 8 ports. Okay, so you see Tmedia 1+1, and network. Okay. Again, these are passive patch panels, so there's no other connection required on those systems. So to install the Tmedia for a 1+1 environment, you need to connect your HA ports, ETH0, ETH1, between the two systems. You connect your TDM ports to the 1+1 patch panel and to the network. You connect the voice over IP ports in bonding or not. But if you have bonding, you must make sure you have your VLANs configured on both switches. And then once you have that, you can start doing your initial configuration. All right. The initial configuration will be slightly different for the primary unit and the secondary. So when you connect to the web browser for the first time, you will get to this page here, which will say, how is this unit to be deployed? All right, so you have the choice of standalone or 1+1 redundant. So here in our case, we will want to use a 1+1. You see here a unit by itself or a 1+1 system like this. All right. Before you get to start this, you must make sure you have your HA communication established, because there will be communication between the primary and secondary unit when you start. So here you just click on continue. If you are configuring the primary unit, you just select here the primary unit. And then if you are installing a new system, you will reply no to this question. Should we get the configuration from the secondary unit? All right, so you reply no to this. If you are replacing a primary unit, that's when you would want to say yes. So for example, you have a 1+1 system that is running traffic and it's available. You decide you want to replace the primary unit. Then when you configure that new primary unit, you will say, please take the configuration from the secondary unit so that I can run normal traffic. Now, when you configure a second, that's it for the primary, right? That's all you have to do. Everything else is configured automatically. Then for the secondary unit, you will just need to specify I am the secondary. So it's possible that this secondary unit has a special license. So when you have a 1+1 system, the licenses are different on the two systems. The primary unit will have all the licenses required to run the system, but the secondary unit will have your 1+1 license to say, well, I need to be the same as what the primary unit is. Okay? And it will synchronize the configuration from the primary always. Okay? Meaning that if you say, I select the secondary unit here, and then you say start, it will take all the configuration from the primary unit and be ready to run. And that's all you need to do, because when you finish this configuration, these units will synchronize together. The 1+1 group will be created automatically in the system. You see here, when you will look in the 1+1 section here, you will see that there's a new 1+1 group that is created. And you will see also that you will have now not only one unit in your configuration, but two units there. You have a standalone system, you have only one unit here. when you want to configure the system, you can connect to any of the unit, either primary or secondary uh, system, and that's fine. Just one thing is the license or the upgrades must be done from the primary. So you can do anything from any device except upgrading or installing new license. If you look at the status, you will have a 1+1 tab that will be available here. And this 1+1 tab will tell you what is the status of your devices, who is active, who is standby, and then if what is the backup unit and is it available, and information like this. Right? And you also get the history information. So you will see if something happened. So for example, yesterday I did some tests. So here you can see that the primary unit was disconnected, so not available anymore. And here the secondary unit was now became active in the system. And here primary unit is not ready, secondary unit is active, backup unit disconnected, and then primary unit is now back active. Right? So when you do these kind of things, you will see that the traffic will be sent either on the primary unit or on the secondary unit of the system. Right? So here I talked about the telecom units, but there's also a portion of the hosts, and these hosts are running the application I mentioned before, like SNMP, traffic, call trace, web portal. So you can see also what is the state of this host. Not super important, but it can give you information, and you can see here who is master of the whole system and who controls the state of the 1+1 system. Not like I said, not so important, but it gives you a state of the system as a whole. To monitor these systems, we want to use either SNMP or our RESTful API. With our RESTful API, you can get status of the system. SNMP is traditional for integrating into a monitoring system. And what you want to monitor are all the interfaces on the system. Okay? So your TDM interfaces, see if they go down, your voice over IP interfaces, your control interfaces, or HA interfaces, signaling links if they go down, if there's application failover, and all of these things. So I gave you just a few elements here if you want to monitor this with SNMP. So state of the interfaces. I'll show you this with a small tool I have for SNMP. The bonding, you can see this also here or from the web portal as well. Well, all of this you can see from the web portal as well, but this is in addition. Primary, secondary, master, slave, host, who is primary, secondary as this time. And then if the applications are running on the primary or secondary unit, so you can get information. So normally you don't care if it's running on primary or secondary, but you care if it switched over. So if it switched over, it means something happened. So there's a good chance it doesn't affect the system, but we should still investigate what happened in those cases. Once you have your monitoring set up, you need to test the reliability of the whole system. So to do this, once the system is installed, you need to verify what happens if I disconnect VoIP 0, what happens if I disconnect VoIP 1, what happens if I disconnect VoIP 0 of the secondary unit, what happens if I disconnect the TDM, right, and one HA link as well. What happens if I shut down a unit? I shut down completely a unit or just reboot a unit, something like this. So you can test if your traffic will be switched from device to device. Now, when we do those kinds of tests, we try to go one at a time to make sure that each element represents something into the monitoring system and that we're able to identify the source and find how to fix that problem. Here, I just show how to do those tests. So these are things that we don't do normally, but we do that when we want to test the system. So you can shut down completely. Once you've installed all your system, it's a good test to do. You shut down completely the primary unit, And then you see if the secondary unit takes over, carries all the traffic, if your links are good. So it's a good idea to do these kinds of tests. The other thing you need to do is prepare an action plan. So if something happens, what do you need to do? So normally, whatever happens in a 1+1 system like this, it won't affect the system. However, you need to fix as soon as possible so that if there's a second failure, it still survives the system. So, for example, if there's a fiber link that goes down, the APS will kick in, and then if one VoIP port, the other VoIP port will kick in. But if you have another VoIP port failure and the APS link failure, then you will get into trouble. So you need to make sure you do this as quickly as possible. So, for example, Ethernet. So you need to verify the switch port status. So this is something that can be done remotely. So if you see the port is down on the telecom unit, you can verify if it's down also on the Ethernet switch. And then if they're down on both sides, then you need to probably check the physical cable. You need to make sure the network switch did not bring down that network interface. And if ever you need to replace a unit in a 1+1 system, then we have some instructions on how to do this using a spare unit on the system. Okay, so let me show you what this means in a system. So here I'm connecting to a 1+1 system. Okay, you see here status. When you look at the status like this in a regular system, and maybe I can just show you here on the standard system, I mean standalone system, you will see that you see there's no 1+1 tab appearing here. So that means this system is running only one unit in the system. In this case, we see that we have a 1+1 system here. Okay, you see two hardware units and a 1+1 group. Okay. You see here now it's the secondary that is active and the primary that is standby. You see all the status here of the system, what was done, what happened in the past hours of the system. Okay? If I go back to the configuration, okay, so actually you had nothing to do here for the configuration. When you configured your primary and secondary system, automatically they were put together into the environment like this, and then you have your primary unit and your secondary unit here. Your 1+1 group was created automatically. It put one unit here and one unit as a 1+1 backup unit. One thing that I should mention here is in the hardware units, if you look at one of those devices, by default the name will be the serial number of the unit like this. Okay, but it's a good idea to change here the name so that it's clear in all the configuration who is primary and who is secondary. If I look at the IP interfaces here, so in the IP interface section, you have, and you go to physical ports, you will see that now you have physical ports from the primary unit and the secondary unit. Right? And these are named exactly the same. And in a 1+1 system, these two ports, physical ports, need to be connected together. TH1 as well. Management is for communicating with the system. And then you have your VoIP port shown as primary and secondary here, primary, secondary. Right? So these are just like the main physical port. If you look at the status of those ports, click on physical ports, you can see on each of the units if it's up or down. Okay, so if one of those ports go down, you will know quickly here, and also in when you do your SNMP monitoring, we'll see that as well. When you configure your bonding here, it's in the virtual port section. And for example, here I have a bonded port And the only thing you need to do is connect them, put two of those ports in a group. If you don't want bonding, then you can use, well, here I don't have examples of non-bonded ports, but you could select only one of the ports here to have your bonding, to not use bonding. And you also have status on the bondings here of the VoIP ports. So if you click on status and bonding here, you will see which interface is currently carrying the traffic, which unit, is carrying the traffic here. And if you see if there has been a switchover of the ports, you will see it here as well. Okay, so for example, VoIP on tag is on VoIP 0 and VoIP 1. You will see it here if it has switched to VoIP. Okay, your 1+1 group, if you look at the status, well, this I showed you already. Okay, so 1+1 group and the history here of the system. Oh, yes, there's one configuration I wanted to show you here in eyes up. So if ever you need to use eyes up, you need to select here primary and secondary. So that's the only other place you need to configure. Because if I configure any of those information here, for example, the MPA traffic here, it is being configured on the primary and the secondary at the same time. Here you see I'm connected on the primary host, and I can just show you my connection to the secondary host. You see here secondary host, and it's the same configuration you have here on both systems. So if I click on M2PA, you see it's the same thing that I have on this interface here. The only thing that will be different on the secondary unit here is the packages and licenses. All right, so if I click on down here, packages and licenses, I get to this page and it says, please connect to the primary host to upload new versions or new licenses. All right, so if I go here on the primary unit, go down to packages and licenses, you will see here that you can upload a new license, upload a new version of this system. Okay. What else did I want to show? Global status. Yeah, host here. So you will see that in host as well, you will have two hosts now, not only one. So you will have two. And if I look at the other system, I have, oops, not this one. This one. If I look at hosts, I have only one element here. Here I have my two elements. Not very, doesn't change much. If you look, oh, let me just go here. Yes, if I go in application, you will see it's running different applications. If one of them is down and not recovering, you will see it here as red. Let's say that doesn't happen very often, but we'll get information on this here. And if you click on the host and in the status, then here is where you could halt the system completely. Okay, so if you do shutdown halt, this will completely halt the system. So this is for testing the system, making sure that your failover works correctly. And this is where you would do this. Yep. So that's all I wanted to show for the 1+1 system. So it's let's say not very different than using a standard system. It's just the initial configuration. You just say, I want to add this configuration into the system. Plus, you need to have your patch panel and your connections done. So there's a part of the connection which requires more work. But once you have your connections done, the configuration is very simple. Everything here is automatic, and there's nothing else to configure here. Okay. So this concludes our training for the 1+1 system. I hope this was useful and that you added more knowledge to this configuration system. Thank you very much.